Hello everyone, I am Madhu. Welcome back to my channel Software Testing World. Today in this video, we'll discuss about the topic integration testing. Let us start about the topic. Here in this video, we'll discuss about software testing levels. What is integration testing? What is the importance of integration testing? Types of integration testing process, and the challenges we are facing in integration testing. First, we'll start with software testing level. Software testing is basically structured into four main levels, each with a specific purpose and its focus. They are unit testing, integration testing, system testing, and acceptance testing. Here I am describing very briefly about the software testing levels because regarding unit testing, if you want more knowledge on this, you can refer to my video, unit testing. And about all these four topics, I'll be posting different videos. You go through that, you'll get more idea on this. So, here in this particular topic, we'll discuss more about integration testing. Unit testing is nothing but testing individual units. So, as I said you prior, you can visit my channel and verify unit testing video. You'll definitely going to get more idea on this. Now we'll start about integration testing. Basically, we are doing integration testing after completion of unit testing. In unit testing, as I said, we are just verifying the dependent programs writing and verifying that the programs whatever is written it's correct or not. Okay, basically unit testing is done by the development team. Integration testing in most of the organization are also done by the development team, and very few organizations there is some software in testing also some integration is there that I'll discuss in later videos. And today we'll discuss what is basically means what is the normal integration testing process. In this integration testing process, basically developers are interconnecting those programs to build a software. It is a level of software testing where individual units or components of the software application are combined as and tested as a group. The purpose of integration testing is to expose the faults in the interaction between the integrated units. After I'm telling you one application or a program, it passed in unit testing, but here in the integration testing, we are just combining both the programs and verifying its flow. Means from one flow, if it is going to other flow, how it is behaving. Here I'll be giving an example. Suppose we are using Gmail or any mail application, any Outlook or wherever. Okay, suppose we are logging in by giving our mail ID and password. After giving all the correct details, so when you are clicking the login button, it is going to the inbox or not. That particular flow we are checking in this integration testing. This is a very small example I have given here. I thought you will be understanding this. So later in this video also I'm going to give you some few more examples. Now we'll discuss what is the importance of integration testing. Means why are we doing integration testing? We are doing integration testing just because of it verifies module interaction. Its meaning is that we are just verifying and confirming that two modules interaction is happening correctly or not. Okay, and the two modules are communicating with each other or not, they are exchanging data or not, and handling each other's response or not. Here we can just consider both failure and success cases. Okay, suppose there are two modules, module A and module B, and we are verifying the module interactions. Then we have to send data from module A to module B and confirm that data sent from module A is received correctly by the module B. Okay, as I have given you that Gmail. Suppose we are composing one mail and clicking on send mail. Okay, whenever we are clicking, when whenever we are clicking on the send button, that mail means we are getting success message or not, and that particular mail whatever we have sent, it is in our sent mail box or not. This is also one example. Another point is that detects interface defects very early. Means it is catching these defects during the integration testing, and it is very time saving and cost saving also. It because if you'll be catching the defects in the integration testing phase, it will help the developer to fix the communication issues. Okay, basically the interaction we are verifying in the integration testing is the communication. So by this testing, we are getting very much beneficial, and we are identifying the problems in how two or more components are communicating with each other as early as possible in the development life cycle. So its importance is very high. So integration testing is playing a very critical role, and it is ensuring that overall system reliability. Okay, how it is verifying by verifying that individual modules will work correctly when they are under a group or they are grouped together. Okay, even if each unit works perfectly on its own, but sometimes when you are integrating both the things, the interaction is getting failed. Okay, so it is validating the communication between the modules and ensures that the right data is getting passed from one module to the other module. Okay, suppose one example here I can give the suppose we are ordering something, the order service sends a valid payment payload or to a payment gateway. That also it is a very important thing. If you'll be getting this kind of error at the system testing phase or in the acceptance testing phase, then it will be very cost effective and very time consuming. So if you'll be getting this kind of defects in as early as in the integration testing phase, so it is very easy for us to resolve this issue. And also it is catching interface defects very early, identifying the misaligned inputs or output, any API mismatch, or any failed method calls, or everything we are getting very early stage in integration testing. So it ensures the system's reliability. Another point is that reduces risk of integration failures later. As this point we have already discussed and covered in these 3 points, means the risk of integration failure, it is reduced by doing integration testing. Okay, it improves the code quality, because if you'll be doing integration testing, that in that page we can able to know what is the problem or flaw it is happening. So the developer will write a very good quality of code that it will not get failed in the future stages of the software development lifecycle. And it's very essential for the complex system. There in complex project, if you'll be getting the errors in the very early stage, and doing we are if we are doing all phases testing, then it will be very easy for us to get the defects in the early stage, and in the latter stage if it will be getting any defects, very difficult for us to get the root cause of that. So integration testing plays a very important role, and it's very essential for complex projects also. Supports continuous integration. As we all know that integration testing is a core part of continuous integration, an automated development practice where code changes are frequently merged and tested and validated to verify or catch the issue very early, so to maintain the stability of the system. So here we have written it supports continuous integration. Now you have completed the importance of integration testing. Now we are going to cover the topic types of integration testing. There are four, basically I have taken here in this video there are four types of integration testing. One is top down approach, bottom up approach, system or big bang approach, and hybrid or sand. First we'll discuss about top. Here I have given one diagram, and here I have represent how top down approach works. Suppose in a particular application, module 1 is developed, module 2 is developed, but module 3 is not developed. Okay, but we have to verify all these three modules integration testing. For that our data has also been fixed. What we'll do in this case, we can do means we can make a stub module. Stub is nothing but a temporary module. Okay, this stub module, a temporary module, will be putting instead of this module 3, and we are verifying that integration testing between module 1 and module 2. As it is developed already, we can verify from module 1 to module 3 or module 2 to module 3, we can verify through this temporary module or stub module. So this process is known as a top down approach, because from this main module is already developed, and the first for the sub modules verification, we have as a sub module is not not developed. So we prepared a temporary module and verified this stub module interaction also. Okay. Here, description also I have written. The testing begins with the top level modules and progresses downwards. That's why it's known as top-down approach. And here we have used a tool that is a stub module. It is a simulate lower level modules not yet developed, as I discussed and I said you. But the approach is major design flaws can be found early. Logical control is tested early. Okay, if there is any flaw, means so it's a very small exam means very small module we are verifying, right, as through integration testing. So if any major issue is there, we can found it in this particular area. That constraint. What is the constraint? Lower modules are tested late. Writing stuff can be time consuming. Yes, it is. Everything has a pros and cons. Okay, as we have to write a stub module instead of this particular module developing the module 3, so it is time consuming, but I feel this is a good one, because if module 3 making developing module 3 will take some 1 week, we can't stop the integration testing till 1 week, right? What we can do, we can make a stub module and we verify this particular functionality, but yes, there is a risk that module 3 will be tested very later. Okay, so it is where it will be best for it is application where control flow is more important. Wherever we are verifying the control flow, in this case, we can use this top-down approach. Now it is the bottom up. In bottom up approach, suppose we have developed module 3, we have developed module 2, but the main module is not yet developed. Okay, what we'll do, for verifying bottom up approach, we have to make a driver. This is also a simulate for the higher level modules. Okay, a temporary program will be right for that higher level module, and we'll put it here as a driver, and we will verify the flow. Okay, so testing begins with the lower level modules and moves forward. Okay, here, as a tool, we are using a driver, and process low level utility functions are tested early. Low level things will be tested early. As a cons, definitely high level logic is not tested until later. Okay, so it is very best use for the systems where lower level functionalities are critical. Some systems are there where lower level functionality will be very critical and higher means higher level are not so much critical. So in that case, we can verify the bottom up approach. Now we'll discuss Big Bang integration. Here in the Big Bang integration, module 1, module 3, module 2, all are developed. Okay, what we'll do the integration testing, then we'll do the integration testing test as a whole system, then we'll verify the output. Okay, here all the modules are integrated and tested as a complete system to in one go. Okay, and it is very simple to implement, no step by step planning is required, but difficult to it counts as difficult to get isolate bugs or error localization is challenging. Okay, it's very best for the small system with fewer modules. If fewer modules are there, we can approach this Big Bang integration testing. Okay, after this we can directly move to system testing phase. Now we'll discuss about sandwich or hybrid integration testing. Here in the sandwich, as the name says, sandwich or hybrid, here we are using both top down and the bottom up approach. See here, what I have done, this is the top down bottom up approach. I have taken module 2 is developed, but module 1 is not developed. I am verifying here bottom up approach, and here in this module 2 to 3, module 3 2 to 4. Okay, this module 4 is not developed, that's why I am using top down approach here. It is mixed up or hybrid of both top down and the bottom up approach. It is a combination of both top down and bottom up approaches. It is a balanced one, and testing can start on both the ends simultaneously. Okay, so it is very complex to manage as we are doing using two approaches here, and requires both stubs and drivers. Okay, so it is best for large and complex system with many layers. Here I have completed all the different approach of software testing. Now we'll discuss about the challenges in integration testing. Okay, there are some challenges in integration testing also. The high setup cost. Okay, it requires a test environment that closely simulates production with multiple components and services, and also it is time consuming and resource intensive to configure and maintain. So for this region, it has a very high cost setup. It is one of the challenge. Then incomplete coverage. Integration testing focuses on interfaces and interaction, not on the internal logic. Okay, we are verifying the flow, not what error is happening inside that internal logic or internal system. So it is a incomplete testing, and we may miss many defects within individual modules that are only tested at the unit level. We may miss, okay, but basically we are verifying the flow over here. Test data management, managing realistic and reusable test data across the integration system is also challenging. Okay, then it may result in unrepresentative test or duplicate effort in settling up the data. Okay, and the most important thing is that it is a not replacement for end-to-end testing. Definitely not, because after unit testing, integration testing is there, and integration testing we are just verifying the flow. So for this reason it is not the end-to-end testing. Okay, and it cannot fully verify business logics, UI interactions, and the performance across the entire system. Definitely we are not doing the entire system testing over here, so it is not a replacement for sure. These are the challenges we are facing in integration testing. Okay. Thank you. Here I have covered all the topics, whatever I have planned to discuss under integration testing. I have covered everything. If you have any doubts, kindly post in the comment box. I'm going to answer your queries. Okay. And if you want to know any new things, that also you can write down in the comment box. I'm going to answer your queries. Thank you so much for watching my video. Hope you enjoyed it. And if you are new to my channel, kindly click on the subscribe button and subscribe to my channel. If you like the video, click on the like button and don't forget to click on the bell icon, because if you'll be clicking on the bell icon and I'll be putting any new videos or uploading any new videos, you can get the notification for them. And as I said you regarding other topics, that is system testing, acceptance testing, unit testing, I'll be in the description box. I'll give you all that links. Kindly go through that and you will be getting more idea on this. Integration testing is a very important interview question, and you are going to, but if development tips does this integration testing, but as I said you, sometimes in testing also we do in integration testing, because as in my experience I could say there is one, I was working on an application in that there are multiple application, and we are basically verifying that how the integration between the application is happening. I can give you examples regarding this latter. um Thank you again. Bye bye.